experiment, we're going to look at the reaction of the formed dimethylaminopyridine with the methyl iodide to see if we can make a prediction from our theoretical calculations on which of the nitrogens is going to be reactive, and then confirm that through infrared and NMR spectroscopy. So it's a fairly simple synthesis here. We're going to do this on a microscale to minimize waste. So we have a very small 10 milliliter round bottom flask, a lot smaller than the ones we used last week. And then we have a reflux condenser here. So I have pre-weighed into here 1 millimole of the dimethylaminopyridine. We're going to add to this about 2 to 2.5 milliliters of methylene chloride. And it's a solvent, so approximate volume is fine. So we've got about 2.4 milliliters here. We're going to add this to this, and we're going to swirl until we get all of our solid to dissolve. Okay, well, most of it's in there. Go a little bit more. So we have an organic starting material, and we have an organic solvent, so we should get good solubility, which we do. All right, we've already dissolved it all in there. Okay, now we're going to add our methyl iodide. Now this stuff is pretty nasty. You got to be really careful with this one. It can methylate your DNA, so have to handle this carefully. And we're going to measure out 62 microliters. Now that's not very much, so we're going to use this micropipetter. I'm going to set it to 62 microliters there. And let's go ahead and draw that up. All right. And then we're going to put that in. Okay. All right. So we have our methyl iodide in there. Now, instead of using a Keck clamp, this actually has a screw top. So we're going to put that on there. Now, I need a way to heat this, and I don't have a heating metal that's this small. So instead, what we're going to do is we're going to use a water bath to get this going. All right. So that's not quite full enough. We'll get some more water here. There's a lot of water. Okay. Once again, we're going to use a water-cooled condenser here. Okay. So I need to connect up my condenser, and just like we've seen previously, we always want to come in on the bottom and then out on the top. Okay. This hose is a little old here. Just get the end off. There we go. Okay. Whoa, in on the bottom. Now, one of the things you have to be careful with a microcondenser, or anytime you're doing microscale chemistry, is that if the temperature goes out of control, you're very easily going to lose the solvent out the top. And so what we're going to do is we're going to keep a thermometer in our hot water bath so we can kind of monitor the temperature and use what we know about the solvent temperature to go. Now, one other thing I do want to add to this is I do want to put in a boiling stone to prevent bumping. Okay, so we just want to put one in, because we're doing the microscale chemistry here. All right, so before I get this all started, let's go ahead and drop in our one boiling stone. I made sure I used a black boiling stone this time because my product is white, and I want to be able to make sure I'm not thinking that my product is, or that my boiling stone isn't part of my product. All right, so we're going to start heating this up a little bit. I need to make sure I get my condenser going now. All right, so let's go. Okay, there we go. Again, I make sure my hoses aren't touching the hot plate. And we're going to get a thermometer, and I'm going to put this in here to monitor it. So I'll come back once I have this going at reflux, and we'll see what's happening. Okay, so we have our dimethylaminopyridine starting to reflux. You can see that there are bubbles forming at the bottom, and you can see the condensation happening up here. So we're going to let this go for about half an hour. Now, you may notice that there's quite a bit of white material that's in the flask already. And if you think about it, when we do our reaction, think about what the product is that's formed and whether it is organic, whether it's ionic or a salt, and think about whether it makes sense that we see this water here. One thing I do want to note really quick, I do have my temperature of my hot plate quite a bit higher than I want my water bath, but remember that a lot of heat is lost to the environment. So I have this set at about 170 degrees for the hot plate itself. However, you can see that the temperature here is right about, well, you can't see it, but it's right about 38 degrees in the water flask, and that makes sense for our solvent. So what we're going to do is we're going to go on ahead and let this reflux for about 30 minutes, and then we'll come back and see what we've got and start to try to clean it up and do some analysis. Okay, we've had 30 minutes of reflux now on the DMAP with the methyl iodide. I just turned off my hot plate. You can still see we get a little bit of condensing going on here. So we want to just cool our system down, and there's a couple ways you can do it, right? You can just pull it right out of the water and you can wait, which works just fine. You can also cool it on ice water or something like that. I'm actually going to take it and I'm going to run cold water over it, but I want you to see what we've made first. Okay, and so good amount of white product here on the sides, a little bit of liquid still on the bottom, so we didn't boil off all of our solvent. That's good here. Okay, so I'm just going to bring this over here, and I got my tubes wrapped up, and I'm going to run some cold water on this. Just make sure we're cool down here. Okay. Now we want to be careful not to get water into our system, as that will affect our yield quite a bit. So I have to be careful just to get the outside there. But now that I'm done with this, we're going to take off my hoses, and then we're going to go over to the vacuum filtration apparatus to try to collect our product here. So